So in this section, we are going to look at a certain theorem which will further explain what I gave it to you in my previous video. And this theorem is the antiderivative theorem. So the antiderivative, the theorem states that the antiderivative of a function f of x is the set of functions f of x plus c such that the dy or such that dy dx of the function f of x plus c is equal to f of x, where the constant c is the constant of integration. As I said, this theorem further explains what I did earlier in my previous video. So what the whole theorem means is that if you have a function f of x, this is my function, and then its antiderivative, which is the integration of this function, the small f of x, is equal to this function, the capital F of x plus c. That is, if the integration of this function, let me try and get a highlight laser pointer T. So that is if the integration of this function here is equal to the function f of x plus c, therefore the dy dx, which is the differentiation of this function here, is equal to f of x. This also restates that, or emphasizes the fact that integration is the reverse of what? Differentiation. And c inside that function is a constant of what? Integration. So before that, let's use this theorem to solve some small example. So basically, first, question 1. Let's take A, the integral of 8 dx. B, the integral of 3x squared dx. C, the integral of e exponent x dx. And then D, the integral of 1 over x dx. So let's take them one after the other. Taking the A here, the integral, using the theorem above here, right? The integral of the function 8 dx is equal to 8x plus c, don't forget that. And if you want to check our answer whether we are correct, we have to differentiate this. When we differentiate this one, what are we getting? We are going to get 8x to the power 1 minus 1, right? And then the differential of a constant is what? 0. Therefore, 1 minus 1 is what? 0. So we are going to get 8x power what? 0, which is equal to what? 8, since x power 0 is equal to 1. Therefore, the answer that we got here, it's correct. So this actually confirms whatever answer that we have gotten from the integration. So basically, that's how it is. Integration of a constant, it's x, or let me say the constant multiplied by x, or that particular variable that we are integrating with respect to. And I will show you the reason why when we get to the power rule. So let's take our second question. The integration of the function 3x squared is equal to 3x 2 plus 1 over 2 plus what? 1. And therefore, it's going to give us 3x power 3 over 3. And it will cancel this one. We are going to get what? X power 3 plus c. So if you want to check your answer, the same thing as we did for the first question, just differentiate this one and you are supposed to get 3x squared back. And we can verify it here. The integral of x power 3 is equal to x power 3 minus 1 and then multiply by 3. You get me? And then the differentiation of that constant is what? Plus 0. And therefore, we are going to get what? 3x what squared. So that verifies our answer. So let's pick the next question. The integration of this exponent x dx is equal to exponent x. And I'll find time to show you the reason why the integration of exponent x is equal to exponent x, and then don't forget the plus c. I'll find time and do a video about it and show you all these things together. I'll pick them one after the other, the lane functions, how to integrate them, the exponential functions, how to integrate them, and the trigonometric functions, how to integrate them. So if you are able to be conversant with such functions and they are combined together to form questions for you, you are going to find yourself very comfortable in dealing with them. So this is the result for the third question, and you can also verify it using the differentiation as well. And the last one, the function, the result is what? Ln x. Then don't forget the plus what? C. And since the fact that the differentiation of ln x is equal to 1 over x, then the integral of 1 over x is equal to what? Ln x. And as I said, don't forget your c is your arbitrary constant of what? Integration. And you can also verify this answer using differentiation as well. So this is what I was talking about for the first theorem, and we are going to get to the second theorem, of which we are going to talk about the constant rule. We are also going to talk about the power rule. We also talk about the natural logarithmic rule, and then finally talk about the exponential rule as well. So thank you and see you in my next video.